Dear students, today we are going to be discussing about shear strength of soil. Myself G. Narendra, Assistant Professor and Rock Engineering College. So, which is comes under Unit 5 of Geotechnical Engineering subject. Previously, we discussed about consolidation of the soil, which is comes under Unit 5. In this regards, we are going to be discuss about what is shear force, what is shear stress, what is shear strength, what causes shear stresses to be induced in soil, what type of factors will be depends upon the shear strength, importance of the shear strength knowledge in for civil engineers, and what is principal plane, what are the methods of finding normal and shear stresses on any plane, and what is meant by Morse Coulomb theory, more Coulomb value criteria with more circle of stress, what factors affecting shear strength of the soil, and finally, how can we measure the shear test? Coming to what is shear force is nothing but a unaligned force which when acts on a body causes the body to move away in the opposite direction. While observing the diagram, the examples cutting of the pages by scissors, tearing of pages by applying two opposite forces, failure of the steel beam due to application of the two opposite forces. Then what is shear stress? Shear stress is defined as the force that causes layer or parts to slide upon each other opposite direction. The shear stress is developed in soil when it is subjected to maximum compressions. By this knowledge, what is shear strength? Shear strength may be defined as the maximum resistance offered by the soil to shear stress just before the failure. That means shear strength. Then what type of factors will be depends on the shear stress. The structural resistance to the displacement of the soil because of interlocking of the particles, and the frictional resistance between individual soil particles as their contact points. Cohesion or adhesion between the surface of the soil particles also will be depends on the shear strength. What is the importance of the shear strength for the knowledge for the civil engineers? The knowledge of the shear strength is very important. Some of the uses provided below. In the design of the foundations, while evaluation of the bearing capacity is dependent upon the shear strength. For the design of the embankments, for dams, road, pavements, excavations, levees, etc. In the design of the earth retaining structures like retaining walls, sheet piles, cofferdams, bulkheads, and other underground structures. What is the principal plane? So, shear strength is subjected to three-dimensional stress system. Actually, soil is subjected to three-dimensional system, but the stresses in third direction are not relevant. Hence, the stress system is simplified as a two-dimensional. Because at every point in a stress body, there are three planes on which shear stress is zero. These planes are called principal planes. The compressive stresses on the principal plane can be maximum or minimum. So if the maximum compressive stress, which is denoted with sigma 1, minimum compressive stress denoted with sigma 3, those are called as a major, minor, principal plane respectively. Then coming to the what are the methods of finding normal shear stresses on any plane of the surface? There are two kinds of the methods we are going to be used for the finding of the normal shear stresses. One is analytical method, second one is graphical method. That is also known as Morse circle method. Analytical method, which is having two types of the cases. Case 1, when we observe the case 1, when the soil is subjected to major and minor principal stresses, vertical and horizontal plane. By analyzing these case, we found that shear stress tau is equals to sigma 1 dash minus sigma 3 dash divided by 2 into sine 2 theta. Sigma dash is equals to sigma 1 dash plus sigma 3 dash divided by 2 plus sigma 1 dash minus sigma 3 divided by 2 into cos 2 theta. Whereas theta is the angle of friction and tau is the shear stress, sigma is the normal or principal stress. Case 2, when we apply the case 2, what it says, when the soil is not subjected to major and minor principal stresses on vertical and horizontal plane, tau is equals to sigma y bar minus sigma x dash into sine 2 theta minus tau into cos 2 theta. Sigma dash is equals to sigma y dash plus sigma x dash divided by 2 plus sigma y dash minus sigma x dash divided by 2 into cos 2 theta plus tau into sine 2 theta. So these two cases which will comes under analytical method to find the normal and shear stresses, whereas graphical method, which is also known as Mohr circle method. So for the drawing of the Mohr circle, we are going to be choose a convenient scale. For example, 1 centimeter is equals to 20 kilonewton per meter square. Then we are going to be plot two axes representing normal stress as well as shear stress respectively, as shown in figure. Then coming to the plot the sigma 1 and sigma 3 value using scale on x-axis. Take sigma 1 plus sigma 3 divided by 2 as a center and draw a circle as shown in figure. Then we are going to be make a plan or plane parallel to the one which is represented in the figure or whose angle of the inclination is known. The plane will cut Mohr circle at certain point. The stresses corresponding to the points will give sigma and tau values for that plane. So sigma 1 minus sigma 3 by 2, that is will give normal stress, whereas normal stress or on the normal stress tau is 0 and tau will be comes from the x-axis to y-axis, how much distance will be there, that is the tau or shear stress. Like that we are going to be finding the normal and the shear stresses by using Mohr circle. Then coming to the Mohr Coulomb theory, it will take more time for the finding. We are going to be discussing about what type of factors will affect shear strength of the soil. The shear strength of the soil will be affected by the soil composition, the soil which is having what type of mineralogy and grain size distribution and its distribution, shape of the particles, pore fluid, etc. The soil composition also will be affected for the shear strength. So the shear strength will be varies by the soil composition. Then coming to the initial state, so whether the loose state or dense state or over consolidated state or normal consolidated state or under consolidated state, it will becomes a factor which will be affected for the shear strength of the soil. And also the structure will be also affected for the shear strength. The arrangement of the particles, whether the packed or distributed in condition. Loading conditions also will be affect the shear strength, whereas effective stress path may be drained or undrained path, what type of loading it will be going. So these are the number of factors will be affected. Now coming to the how can we determine the shear strength parameters like cohesion, friction. So by using different kind of the laboratory test, also field tests also we are going to be conducting for the finding of the shear strength. So laboratory test, it will becomes direct shear or vane shear and triaxial shear test. The triaxial shear test will be having three different divisions or dividing into different tests, whereas the field test, the number of field tests will be going to be conducting by the constructing of the pavement or constructing of the roads, like that. So vein shear test, it will be comes under laboratory as well as field test. The second one is Thor vein, third one is pocket penetrometer, fourth one is Falcon, fifth one is pressure meter, sixth one is static cone penetrometer, seventh one standard penetration test SPT. It will be SPT test. So like that, the number of tests we are going to be conducting for the finding of the shear strength of the soil. So whereas here we are going to be field condition, how it will be a representative soil sample we are observing by applying the load, the soil how it will be acts before construction soil and how it will be after and during the construction soil condition, or a soil element how it will be acts. Just we are observing the diagram. While seeing the diagram we can understand the soil condition. Now coming to the direct shear test, we are observing the diagram, that is the schematic diagram of the direct shear apparatus. The operator consisting of number of component parts also. And while preparation of the sand specimen, just we are taking the sand particles and we are placing into the mold, and then we are going to be applying the load on the soil specimen. Just we are observing porous plates. Between the porous plates the soil sample will be, and steel bar and also pressure plate we are observing here, and providing to the measurement of the shear force, that the dial gauge reading also will be comes. So here the steps, step 1 and step 2 we are observing applying a vertical load to the specimen and wait for the consolidation. And step 2 is lower box is subjected to horizontal displacement at a constant rate. So whenever we apply the load, the lower box it will be goes or slides slowly or gradually, and apply or and observing the shear how it will be occurs. So that we are going to be finding the shear strength. So how much amount of shear it will be resisted, that will be we find out by using direct shear test. So here the formula, sigma is equals to normal stress, that is normal force divided by area of cross sectional of the sample, and tau is equals to shear stress, shear resistance developed by the sliding surface divided by area of cross sectional of the sample. So then the graphical representation while conducting the test, or after completion of the test conduction, we are going to be draw the graph. So just we are observing the dense sand how it will becomes the graphical representation between the shear displacement and shear stress, and loose sand how it will be occurs. So that we are observing the different kinds of the stresses, different kinds of the soils, normal stress, whereas normal stress also three kinds, sigma 1, sigma 2, sigma 3. So corresponding of the shear stresses, tau 1, tau f1, tau f2, tau f3. So like that direct shear stress on the sands, the different graphical representation it will becomes. Just we observe in the laboratory by conducting of direct shear test on the particular soil. Then coming to the direct shear test on the clay soil. So that is also we can observe by conducting of or by applying of the load on particular soil, that is clay. And what are the advantages of the direct shear apparatus? Due to the smaller thickness of the sample, rapid drainage can be achieved. That is the first advantage of the direct shear test. Second one is we can be used to determine the interface strength parameters. Third one is clay samples can be oriented along the plane of the weakness or an identified failure plane also. So what are the disadvantages? Failure occur along the predetermined failure plane. Second one is area of the sliding surface changes as the test progresses. Third one is non-uniform distribution of the shear stress along the failure surface. Like that, the direct shear stress will may be conducted. And coming to the triaxial shear stress also we can observe. First of all, we are going to be preparation of the sample, and then we are going to be applying the load in the triaxial shear test apparatus. And then we can observe by applying the load what type of failure plane will be comes. So this is the failure plane. The red mark shows about the failure plane, and blue mark it will be normal consolidated, and red mark is over consolidated clay soil. So that we can understood the triaxial test also. And triaxial test, it will be dividing into three kinds of the tests. One is CD test, second one is unconfined compression test, and third one is undrained unconfined undrained test, UU test, that means. So the procedure may be like this, and then the graphical representation it will becomes like this. And the vein shear test, this is also which is comes in the field as well as laboratory test. The formula is like this: shear strength of the soil, that is equals to T divided by pi d square into HT2 plus DT6, whereas T is the torque, D is the diameter of the vein, H is the height of the vein, so that we can find out the shear strength. So like that, the different kinds of the tests we can conduct for the finding of the shear stress, shear strength. Then where we going to we apply the knowledge? The shear strength knowledge we can apply in the gate point of view, mainly gate examination point of view. The number of questions may be asked like this: the most appropriate triaxial test to assess the long-term stability of an excavated clay slope is. So already we can see in the triaxial test. The triaxial test, which is dividing into three different tests, those are called as a drained test. So unconfined drain test. So the three tests are called consolidation drain test, second one is unconsolidated drain test, and third one is unconfined compression test, UU test. So here the answer is the most appropriate triaxial test to assess the long-term stability. So if we get the long-term stability, if you want the long-term stability for the excavated clay slope, we go for the consolidated drain test. That is the first question we can see. Second one is the Morse diagram. A point above the Morse envelope indicates safe condition, imaginary condition, imminent failure condition, and the fourth one is condition of the maximum ability. So when we observe the Morse envelope diagram, just we observe here. So this is the Morse envelope failure theory, or failure circles or half circles we are observing here. While drawing the half circles of the Morse Coulomb failure envelope, just we imagine the starting point, it will be start from the origin to the ending point, it will be takes a angle that is pi. So which is the imaginary line, which is nothing but a imaginary line. So asking the question like this only here. In Morse diagram, a point above Morse envelope indicates which is a safe condition, imaginary condition, imminent failure condition, and the last one is condition of the maximum ability. So which is a imaginary condition. So the line which is imaginary line, so that we can say that that is imaginary condition. The third one is the determination of the shear strength of a soft saturated clay deposit in the field can be done by whereas the vane shear test, triaxial shear test, direct shear test, and the last one is unconfined compression test. So which is vane shear test only. So actually we did not see the vane shear test. We can see in the classroom how it will be conducted and what type of material which is suitable. So here first point only, it is suitable for the undisturbed for remolding samples cannot be got for the conducting of the triaxial or unconfined compression test. The shear strength is determined by the device called as a shear vane shear test. So the determination of the shear strength of the soft saturated clay deposit in the field can be done by the vane shear test. So like that we can apply the knowledge of the shear strength not only for the writing of the semester examination, but also we can share but also we can use the knowledge in the gate point of view as well as public sector examination point of view also. So if you have any doubts, you can ask me freely, and you can post the comments in the comment box. Thank you very much.